A very good morning. My name is Nikhil Dogra, and today I am going to teach carbonyl compounds. So, to highlight the importance of carbonyl compounds, I will first ask you a few questions. So, have you ever wondered why the nail paint remover has a certain typical smell? Then, if we see the household, or if we specifically go to kitchen, then we have many things, or many, for example, cinnamon we have seen has a typical smell. Then, if we talk about vanilla, that we usually use in ice creams and other chocolates, etc., we see it has a typical smell as well as a typical flavor. Then, if we further go to our traditional activities or our temples, we see camphor has been used a lot there. So, how these different flavors and fragrances are coming? Where do they are coming from? So, the answer to all would be carbonyl functionality. So now you would be probably thinking that carbonyl functionality is only specific to the flavors and fragrances. Then if you're thinking so, then you are wrong. So if I talk about the biological systems, for example, if I talk about the body, human body or any body, so there are a lot of biochemical reactions are occurring every seconds. For example, if I have to give you an interesting fact, then let's suppose that if X amount of total number of grains of sands are there in on this whole planet Earth, then even thousand or 10,000 times more are the biochemical reactions that are occurring in our body every second. And in these all the reactions, at least 50 to 60% reactions are there, which include carbonyl compounds directly or indirectly. So now we have talked a lot about the significance of carbonyl compounds. We'll now see what carbonyl compounds are or what exactly carbonyl functionality is. So I'll begin by drawing the structure of carbonyl compounds. So first we'll see what is the carbonyl functionality. So carbonyl functionality is a functional group which contains carbon and oxygen. So in between carbon and oxygen, there is a double bond here. So if we closely see the structure of this carbonyl compound, we see that there is a carbon and the another one is oxygen. So we know that carbon forms four bonds. One, two, three, four. Out of these four bonds, there are three sigma bonds. For example, first sigma bond, second sigma bond, and this one is the third sigma bond. Now, this remaining bond here is the pi bond. Pi bond basically it is usually formed by the we can say sideways overlapping between the orbitals. For example, if these are orbitals, these are the pure or p orbitals of carbon and oxygen, then when there will be sideways overlap, there will be a formation of pi bond. And sigma bonds also they are formed from the head to head overlap. For example, if this is carbon, like let's say this is carbon here, and if we take the, so there will be formation of head to head overlap. So this bond, and then there will be another, let's say this is methyl. So these orbitals, they both will overlap head to head, which will give us a sigma bond. And sideways overlap, as I earlier mentioned, it is a pi, it will be forming a pi bond. So that was the structure of a carbonyl group. Let's briefly talk about the hybridization of carbonyl. So as I said, carbonyl has a carbon center, bonded double bond oxygen. So we see this carbon is the central atom here. For knowing the hybridization of this carbon, we so how do we find the hybridization? First, we will see. So hybridization. For counting the hybridization, we find the number of sigma bonds plus number of lone pairs that are there involved in the center with the central atom. So here central atom is the carbon, as I mentioned. Now we'll see how many sigma bonds and how many lone pairs are there. If we see carbon, it has already completed its octet rule here. For example, 1, 2, 3, 4, 5, 6, 7, 8. So there are total 8 electrons over here, and 8 electrons means the octet of carbon is complete now. We will see the hybridization now. So as I said, all the octet rule is completed here. So we see there is no lone pair, and so the thing is that only sigma bonds are left here. So only how many sigma bonds are there? As I said, there are 3 sigma bonds in this carbonyl moiety. So the hybridization for 3 bonds. I said 3 bonds are there. So 3 bonds would be requiring 3 orbitals. So these orbitals will be S, and the remaining 2 orbitals will be P. So the hybridization will be sp2. For visualizing the angle of sp2, it looks like a like it is like this. This hybridization is like this. So we can assume kind of a triangle here. And for finding the bond angle, what we will see that if this is a triangle kind of, then if we draw from the corners to the center, we'll see that each angle would be 120 degree. Why 120 degree? Because the sum of all the angles would be 360. So 360 divided by 3 would be 120 degree only. And why are we comparing it with the triangle? Is that because this functionality is a planar functionality. Now, planar, what does planar mean? Let's suppose this whole green board, it is a kind of a plane. Plane may be the page, plane of board, anything. So all these 8, 1, 2, 3, all these will be lying in a single plane only. So that is the planarity of the functional group. Just for example, to compare with other functional groups for other molecules, let's say, if I talk about methane, then we know methane is a tetrahedral molecule. So we can just a second. So methane, so it is like so it is a tetrahedral shape. We see two bonds are in plane. Let's say these bonds will be in the plane of the board. This bond, which is shown through a wedge, would be coming out of the plane, and this this bond, which is dash bond, it would be going inside the plane of board. So that is a difference between a planar geometry versus a non-planar geometry. So that was the structure of carbonyl compound. So I'm talking about carbonyl compounds. So what are carbonyl compounds first? We'll see. So carbonyl compounds are the compounds which contain carbonyl functional group. For example, if we talk about the specifications or the types of carbonyl compounds, we'll see this is a carbonyl functional moiety. Now these two bonds have formed between with the oxygen. Now these two valencies are still we have not filled them. So we will see what can they be. So we can see if we attach a hydrogen over here like this. So that would form a functional group, another functional group, which we call as an aldehyde. And the another function, the another valency that is still not we have failed yet. Let's say if it is a carbon chain. R we represent a carbon chain. R may be methyl, ethyl, or any carbon chain, any carbon chain it can be. So that will be an aldehyde. The another specification, the another possibility that is here that we can say is if it is a carbonyl, then both sides can be uh, substituted by an alkyl group. So like for example R, or instead of R, this can be aromatic chain as well. So that basically forms a ketone. So this is called a ketone. So if we talk about carbonyl compounds, we mainly see aldehydes and ketones. And there may be another possibility. For example, if one can say that, what if both sides, on both sides there is hydrogen? That is also one of the possibilities. So yes, this is also possibility. And since we saw that there is a functional group containing hydrogen carbonyl, it is an aldehyde. On another side also there is a functional, so it is overall an aldehyde. So the common name we can give to it would be the formaldehyde. So there is another class of carbonyl compounds as well, which includes carboxylic acids, amides and its derivatives, etc. But since they include one more functional group along with carbonyl, so we'll be talking about them later. So we'll restrict ourselves to ketones and aldehydes only till now. So now, since we have had a brief talking about the what carbonyl group is, what are carbonyl compounds, what are aldehydes, what are ketones, what is the hybridization of carbonyl, we will now see the features of this carbonyl compounds. So again, I'm going to draw the carbonyl functionality first. So this is the carbonyl functionality. So if we talk about the feature, the first feature would be polarity of the carbonyl compounds. So first one would be the polarity. Now where does this polarity comes from? We'll see. So we know that oxygen is an electronegative atom. So in periodic table, the most electronegative atoms are fluorine, oxygen and nitrogen. We know fluorine is the most electronegative atom of the electronegative atom of the periodic table. So fluorine followed by oxygen and followed. So oxygen has also a very good electronegativity. Just a small recap of what electronegativity is. So electronegativity is basically the tendency to attract the low electron pair from shared bond. For example, uh, here we like just for example, C X is any electronegative atom. So X, because of its electronegativity and small size, it will withdraw electron density from this carbon. So it will withdraw through this bond only, this bond. So what will happen? This would acquire a negative charge since it has gained some electron density. So it would be having a negative charge, and this has become now electron deficient. So it would be acquiring the positive charge now. So same goes for the carbonyl compound as well. So this carbonyl compound has a oxygen attached to it. So it will withdraw the electron density from carbon, which will create a partially negative charge over the oxygen and a partially positive charge over the carbon. So this give rise to polarity. Since polarity, basically it now bond has been polarized, one has attracted the electron density and one has given the electron density. Now what is the consequence of the polarity? We will see the memo the it will help in the reactions of the carbonyl compounds. So we'll again see this. So I'm drawing this again. So this is a carbon compound. As I said, this carbon is partially positive in nature, this oxygen is partially negative in nature. Now in chemistry we have two things. First one is a nucleophile and another one is an electrophile. Now what is a nucleophile? So nucleophile, as the name is suggesting, nucleo comes from the word nucleus. What is nucleus? Nucleus is coming from, when we talk about the atom, the nucleus is a positively charged center around which electrons are revolving every time. So that is a nucleus. So basically nucleus refers to the positive charge. So nucleophile, what word is nucleophile? Phile is a word which means loving. So a nucleophile is nucleus loving. Nucleus loving means positive charge loving. Now in this center we have two centers, negatively charged and positively charged. So if a nucleophile, so just 1 second, nucleophile is a positively charged species, sorry, positive loving species. So it would itself, what do you think? What kind of charge would it be having? Of course, it would be having a negative charge. Since if it has negative charge, then only it would be going to a positive charge. That would that don't then only it will be positive charge loving. So we see nucleophile can be represented like this, like a negative charge on it. Does not mean nucleophile is always charged species. It may be neutral. For example, ammonia. Ammonia has no negative charge over it, still it is a nucleophile. Since it has this lone pair which has electron density, it would love to get a positive charge loving species. So nucleophile, for let's say, examples of charged nucleophile can be, for example, OH negative. Done. So now this coming to carbonyl group. Carbonyl group has two centers, negatively charged center, positively charged center. So the nucleophile, where will it go? Of course, nucleophile will go to a positively charged center. So nucleophile will come, it will attack onto this positively charged center. Now, since carbon can form only four bonds, so what will happen? This pi bond, since we know that pi bonds are weak bonds compared to sigma bonds. So when this will attack, this pi bond will go to the oxygen. So now what will be it forming? You see, there will be a negative charge on oxygen since this bond has broken and it hydrolytically been broken, and it goes to negative. So it will be CO negative. Then there is that whatever it was, and the nucleophile would be there. So from going here to there, we see a significant change. That is, we see the geometry is changing. We earlier had a sp2 hybridized carbon, which is now been converting into sp3 carbon, sp3 hybridized carbon. Since four bonds, so sp3. So one will be, two will be in the plane, one will be out of the plane, and another will be in towards the plane. So this intermediate has formed tetrahedral intermediate we have formed. So now further this O negative, they will it will react with the proton. So kind of the such reaction will occur. So that was the about reactivity of carbon. Now we see other features of this functional group. So till now we talked about the reactivity of this carbon center. Now we see there is another center which is having negative charge, or partial negative charge. So since it has a negative charge, so a species which carries positive charge can attack here. Let's say proton can attack there. So which, so basically it is electron density loving. So we call it as an electrophile. So this will attack on the, now you will be wondering why I have made arrow from here to here or not here from there. The reason simply is that the arrows are always drawn from negative charge to positive charge. So here this is happening like this, and then we will be ending up like having a species like this. So now what will be the consequence of this is that now this oxygen is having positive charge. That means the nucleus has become now more stronger, so it will withdraw electron density more and more, and this carbon center will be becoming more and more electron deficient. So the reactivity of this carbon center will be increased. So any nucleophile now can attack here with very easily. So since the electrophilicity of this carbon has increased. So that was about the reactivity of the carbonyl center. Just to summarize this in one line, so this is carbon center containing carbon oxygen double bond. Carbon has a positive charge, oxygen has a negative charge due to the electron density. This carbon can be attacked by a nucleophile, and this oxygen having negative electron density can be attacked about an electrophile which has a positive electron density. Oh, sorry. The arrow should always be from negative to positive. So like this. So that was how the reactivity comes into picture for carbonyl compounds. So that was all from my side. Thank you.